In this session, we will discuss about how we can construct a signal flow graph. So, the first question is, construct a signal flow graph for the armature controlled DC motor. So, that is the question. So, what we have to do is that first of all, we have to derive the differential equation of a armature controlled DC motor. Then we have to convert those differential equation to Laplace transform domain, that is to S domain. And we have to identify input and output variables, and we have to represent each of the equations separately by drawing the signal flow graph, and then at final stage we have to combine all these signal flow graph in order to get the overall signal flow graph for armature controlled DC motor. So in the previous class we got the equations for armature controlled DC motor. We have studied about armature controlled DC motor. So in that class I told you to by heart those equations. So there are 5 equations in the case of armature controlled DC motor. So we can write those 5 equations and the differential equations. So the solution starts from here. The differential equations governing the armature controlled DC motor are VA is equal to IA into RA plus LA into DIA by DT plus EB. That is for the electrical circuit. And also we know that torque T equal to KT into IA. And also another equation, torque T equal to J into d omega by dt plus v omega, that is for mechanical system equation. And also we know that induced voltage EB equal to KB into omega and omega equal to d theta by dt. These are the 5 equations and we have to take the Laplace transform of these 5 equations. So we will get VA of S is equal to IA of S into RA plus LA into S into IA of S plus EB of S. That is first equation, that is equation number 1. And next for the second equation, T of S is equal to KT into IA of S, that is second equation. And next T of S is equal to JS into omega of S plus B into omega of S, that is third equation. EB of S is equal to KB into omega of S, that is fourth equation. And omega of S is equal to S into theta of S, that is the fifth equation. Okay. So we have VA of S, T of S, 2 equations for T of S and EB of S and omega of S. So the input and output variables of armature controlled DC motor are armature voltage is the input and output is angular displacement, that is theta of S. And the variables are IA of S, T of S, EB of S and omega of S are intermediate variables. So in order to draw the signal flow graph, first of all we should understand the input and output and intermediate variables. That is, I am stressing out that input and output are VA of S and theta of S. Intermediate variables are IA of S, T of S, EB of S and omega of S. That we are getting from the equations. Okay. So the equation 1 to 5 are rearranged and individual signal flow graph can be drawn. Okay. So we can start to draw the signal flow graph. First of all we are taking first equation, equation 1. Okay. That is, we have first equation that VA of S is equal to IA of S, R of S plus LA into S, IA of S plus EB of S. In that equation, first equation, we can take EB of S to the left of equal to symbol. So we will get VA of S minus EB of S is equal to IA of S can be taken outside. So IA of S into RA plus SLA. Okay. So we can write the equation as VA of S minus EB of S equal to IA of S into RA plus SLA. And in that equation, IA of S can be written as 1 by RA SLA into VA of S minus EB of S. So we know that IA of S is the intermediate variable. So if VA of S minus EB of S is the input, then IA of S is the output. That is an intermediate variable. Okay. So we know that VA of S is the input and theta of S is the original output, and IA of S are intermediate variable, and also IA of S intermediate variable can be represented in terms of VA of S minus EB of S. So we can draw starting from VA of S, that is the input variable, and it goes to another node, and that another node is the difference between VA of S minus EB of S. So second node we can represent as VA of S minus EB of S. So we have to show the EB of S also, that is coming from another node, that is shown at the downside, at the lower side, lower portion in figure 1. Okay. So EB of S comes to the node where VA of S minus EB of S is there. We know that EB of S is subtracted from VA of S, so we should put a minus 1 gain on the line connecting EB of S and VA of S minus EB of S. Okay, and we know that the intermediate variable IA of S is obtained by multiplication of VA of S minus EB of S by a factor 1 by RA plus SLA. So we should draw another node which is represented by a circle where we can represent the intermediate variable IA of S, and the gain of that branch will be 1 by RA plus SLA. So from the equation 1 we will get the signal flow graph which is shown in the figure 1. Okay. So next we have to consider the second equation. What is the second equation? Second equation is T of S is equal to KT into IA of S. So we can write it T of S is equal to KT into IA of S. See here, IA of S is an intermediate variable, and when IA of S is multiplied by KT we will get a T of S. So we can draw it by representing two nodes where one node is IA of S and then it is multiplied by KT and we will get T of S. So input is IA of S in this case and output is T of S. So we can represent the gain of the branch as KT. So from the second equation we got this signal flow graph. Okay, and next we will consider the third equation. In the third equation, T of S is equal to Js into omega of S plus B into omega of S. Omega of S can be taken outside. Okay, so we will get T of S is equal to Js plus B into omega of S. So that is represented by like this, T of S is equal to omega S into Js plus B. In this case, omega S is equal to 1 by Js plus B into T of S. That means omega S is obtained by multiplying T of S by 1 by Js plus B. That means in the previous session we got T of S as output and IA of S as the input. And whenever T of S is multiplied by 1 by Js plus B, T of S is multiplied by 1 plus Js plus B, we will get omega of S. So we can draw the signal flow graph as T of S is there, omega of S is at another node. So the multiplication factor is gain. So 1 by Js plus B is there in the position of gain. So next we have to consider the equation number 4, that is EB of S is equal to KB into omega of S. Okay, that means when omega of S is multiplied by KB we will get the EB of S, error signal. Okay, so we have now the omega of S in the figure 3. So whenever this omega of S is multiplied by KB we will get the EB of S. But we know that from the first figure 1, EB of S is shown at the lower portion. So from omega of S we can draw a node. We have got up to this point, we have got omega of S. When omega of S is multiplied by KB we will get the EB of S. So we can draw a line like this. Okay, figure 4 shows that omega of S from figure 3 goes to EB of S. Okay, so in this textbook it is shown that EA of S, that is by mistake, actually it is EB of S. Okay, so omega of S goes to EB of S and its branch gain will be KB. Okay, and next we will consider the fifth equation. What is fifth equation? That is omega of S is equal to S into theta of S. Okay, so we can rearrange that equation as omega of S is equal to S into theta of S. We know that theta of S is the output. We can take S to omega S side, so we will get theta of S is equal to 1 by S in omega S. That means whenever omega S is multiplied by 1 by S, we will get the output of the original system, that is theta of S. So it can be shown by two nodes and its gain is 1 by S. So we have 5 figures and we can combine all these figures in order to get the overall gain. So we know that from each of the signal flow graph, in the first case the output is IA of S, that IA of S is connected to the second figure. Sorry, IA of S is then connected to T of S, and then T of S is connected to omega of S, and omega of S is then connected to EA of S, EB of S, and EB of S is the feedback path, and where EB of S is shown in the figure 1 at the lower portion, and also from the omega of S it comes to theta of s. So by combining all these signal flow graph, we got a signal flow graph like this. Okay, in this case you should mark the arrow mark also in each of the diagrams which shows the flow of the signal. Okay, so from in the first figure it goes up to Ia of s. Okay, Ia of s, and there is Eb of s also, and Ia of s then gives to T of s and its gain is Kt, and T of s2 it will goes to omega of s and its gain is 1 by Js plus b, and from omega s2 first it will go to Eb of s and its gain is Kb, and then from omega of s it will goes to theta of s and its gain is 1 by s. That is the way how we can join all these signal flow graph in order to get the original signal flow graph for armature controlled DC motor. So we should have an idea about the input and output. We know the working of armature controlled DC motor, so we will get the idea. So we can easily draw the signal flow graph. This is one example for constructing the signal flow graph. Similarly, you can draw the signal flow graph for field controlled DC motor also. I am not discussing it. You can do it yourself. Okay.